This is a review for the Geometry Semester 1 exam. We're going to go through this page by page. There are 48 questions on this review total. Actually, I think there's 51. It got misnumbered on the second page, but there's 50 or 51 questions total. All right, number 1, fill in the blanks. Study all your geometry vocabulary. So you can go back and starting in chapter 1, you can go back and look through if you're not sure what some of these are. The intersection of two non-collinear rays at a common endpoint is known as an angle. Right? We have two rays. Here's a ray, has one endpoint, one that extends forever. Here's another ray. They're not in a straight line, they're non-collinear. So when they meet up, they form an angle. Okay, second one, a blank is a location. It has neither shape nor size, a point. Right? A point would be like there. No length, no width, no depth. All right, next, blank lines are two distinct coplanar lines that do not intersect. That's parallel lines. Two lines on the same flat surface. That's not a very good drawing of parallel lines. But the two lines never cross over each other. So they are coplanar, but they never intersect. A flat surface made up of points that extend infinitely in all directions is a plane. P-L-A-N-E, plane. All right, number 2, determine which of the following statements are true if triangle, C-A-T, is congruent to triangle, L-U-V. This is not multiple choice, so you're not just picking one answer here. You're selecting all of the ones that are true. All right, so whenever they give you the name, congruency statement with triangle names in it, you want to pay close attention to the order of the letters. They matter. They are corresponding. So this first letter here corresponds to the first letter here. It means the angle at this point is congruent to the angle at this point, since the two triangles are congruent. The angle at point A is congruent to the angle at point U. Same with T and V. Line CA, line segment, is congruent to line segment LU. Everything's congruent if it's in the same position. All right, A, angle C is congruent to angle L. C is the first letter here, L is the first letter here, so yes, that is true. Let's circle that one. True. B, CA is congruent to VU. CA, that's the first two letters here. VU, oh, that's not the first two letters here. LU are the first two. So this line segment CA is congruent. So this line segment CA is congruent to LU, not UV. So this is not true. This is however you want to, I don't care how you mark it, but if it was on the computer, you would like select, it would give you a way to select each of these, but we don't have that capability here. C, TCA is congruent to VLU. Okay, so let's look at the order of TCA. What did they do here? They last letter, first letter, middle. Last, first, middle. So for the angle over here to be congruent, it would have to be last, first, middle. So VLU. VLU, that works. TCA, last, first, middle, is congruent to last, first, middle. VLU, that works. So that's correct. D, TA is congruent to VU. TA are these second two letters. VU are these second two letters. The last two, that is true. So that is correct. And then E, this last one here, angle TAC. So basically we just went backwards. We have this triangle CAT. So for angle TAC, we went backwards. It would have to be congruent to these letters backwards, VUL. And it is VUL. That's what it says. So that is true as well. So the only one here that was not true was the second guy, B. This was not true. Everything else was true. Number 3, explain how to prove that the two triangles are congruent using side angle side, given D is the midpoint of BC. So here's BC, D is the midpoint, okay? So we have to explain. So let's just talk through it, right? If we know D is the midpoint of AC, then we know that this side, AD, is congruent to this side, DC. So we can say BD is congruent to DC because of the midpoint theorem, right? Or the definition of midpoint, just put midpoint. This is our explanation. So this was step 1. Okay, step 2, this is marked a 90-degree angle, right? It's marked that way. So if we know this angle is 90, this line forms that 90-degree angle here. So that means this angle has to be 90 because these two angles are supplementary. They make up a linear pair, right? So we can say angle BDA, angle BDA is congruent to angle CDA, which is equal to 90 degrees, right? So we know that's true because they make up a linear pair. So now we know these sides are congruent, this angle is congruent, and we know that both triangles share this line, AD, this line segment. So we know that AD is congruent to AD. So now we've proven that the side, angle, and side of one triangle are congruent to the side, angle, and side of another triangle. So that's side, angle, side. These two triangles are congruent because of side, angle, side. Okay, number 4. And if you have questions on these, if I'm not answering them adequately, please let me know and I'll be happy to go into further explanation. Number 4, what statement will be needed to prove that the two triangles are congruent? Using angle, side, angle. Okay, so it tells us angle KJL, this guy, is congruent to NML, this guy right here. Okay, so it tells us that here in the given. It shows us in the picture that this line is congruent to this line. And we know the one statement that's missing is that this angle is congruent to this angle because they are vertical, right? So we can say angle JLK is congruent to angle MLN, or you could say NLM, because they are vertical angles. And once we've proven those 3 things, we have angle, side, angle, congruent to angle, side, angle, right? 2 separate triangles with 2 angles and a side congruent to 2 angles and the included side here. All right, number 5. Which postulate or theorem can be used, sorry, that's crooked, to prove the following triangles are congruent? Write a congruency statement for each pair of triangles. This is not multiple choice, so we're answering, this is like 3 questions here. Which postulate or theorem can be used to prove the following triangles are congruent? All right, so for this guy, all it shows is that the top is congruent or parallel to the bottom and that the sides are parallel, right? And that they are cut by this transversal. Okay, so whether, let me find a different colored pen here, whether we're talking about the distance from that transversal to the top or the transversal to the bottom, we know these 2 angles are the same because these 2 lines are parallel. So the measure from this diagonal to the top is the same size as the diagonal to the bottom, since the bottom and the top are parallel. The other thing we know is the same, that is the same, getting like slurring my speech today. This angle here is congruent to this angle here because this is measuring this diagonal to this line, and this one's measuring the diagonal to this line, and these 2 lines are parallel, they're marked, right? And then we also know both triangles share this middle line. So angle, side, angle, right? This is angle, side, angle. So we want to write a congruency statement. I'm going to say, start with this angle up here. SRT, triangle SRT, is congruent to, and I started up here with S, which is this single angle. So I need to, in this triangle, I need to start with the single angle. This is TUS, triangle TUS. So T corresponds with S. This T corresponds with this S. This U corresponds with this R. They're both in the middle. And the other T corresponds with the other S, right? So we listed that out. And what was the reason? Which postulate or theorem? It was by angle, side, angle. If you wanted to be an overachiever and say that we use the alternate interior angle theorem, you could. But the main thing they're looking for here is angle, side, angle. We did use this postulate though, alternate interior angle theorem. That was saying the top, these 2 are congruent and these 2 are congruent. Okay, next one. Here they have the top marked congruent to the bottom. And they have the side, this guy, marked congruent to this guy. You have the 2 lines here and the 2 lines here. And then we can quite plainly see that this third side is shared by both triangles, right? So my two triangles are congruent because of the side, side, side theorem. So I can say triangle, I'm going to say FHJ is congruent to triangle. If I started here, HJ, I'm going to start with here, JGF. Okay, and that is because of the side, side, side theorem. And that's all we use there, okay? And then lastly here, we have this bow tie shape. This side in this top triangle is marked congruent to this side in the bottom. This side in the top triangle is marked congruent to this side in the bottom. And then we know in any bow tie shape that these angles, these vertical angles are congruent, right? So we can say that, here's my purple, triangle, the top guy, so I'll say X, Z, Y is congruent to, doesn't matter what order you do the letters in, but whatever order you do one triangle in, you have to do the corresponding order in the other. I started up here on the end of this red line, so I'm going to start down here at the end of this red line, W, Z, V. And I know that these are congruent because of the side, angle, side postulate, right? Side, angle, side is congruent to side, angle, side. And then if you wanted to be an overachiever, we also use the vertical angle theorem, or definition of vertical angles, but you don't have to say that. They were looking for the SAS postulate. All right, and then number 4, end of the first page. If the triangles below, of the triangles below maybe, angles A and D are congruent. So this guy is congruent to this guy. C is congruent to F. This guy is congruent to this guy. B is congruent to E. I'll do that in purple. 1, 2, 3. 1, 2, 3. What can we conclude? Are the triangles congruent? Why or why not? Well, do they look congruent? No, one's bigger than the other. If all 3 sides are congruent, then we know the 2 triangles are congruent. However, if all 3 angles are congruent, that still does not mean the triangles are congruent. Think about a box, right? If we were looking at a square, we could have a little teeny tiny square and all 4 corners are 90 degrees, right? Or we could have a humongous square. This is my humongous square. And still, all 4 corners are 90 degrees. So are these 2 squares congruent? Are they the same size? No. Well, all their angles are the same size. Why aren't they the same size? Because it doesn't matter. The side lengths can be different. They can have the same angle measure, but if the sides aren't the same, they're not congruent. So we cannot conclude that these are congruent. Not congruent. Sometimes they could be congruent, but not necessarily. We have to know something about the side lengths. What can we conclude? We haven't really gone over this, but the 2 triangles are similar, meaning they have the same proportions, right? So we can say they are similar. Similar just means if you took one triangle and you increased it proportionately, so it looks exactly like it was, it's just bigger or smaller, then it's a similar triangle, right? If it's a completely different shape and proportionally it's just totally off, then they're not similar. Like for example, if I had an equilateral triangle and I had another equilateral triangle, right? All sides, let's say, are 3 here. All sides of this one are 8. These 2 triangles are similar because they're equilateral triangles. One's just bigger than the other, right? If I had an equilateral triangle, 3, 3, 3, and then I had a right triangle, 2, 9, let's say 7, I don't know if that even works out, whatever. These are not similar. I didn't just increase this to get this one, right? It didn't proportionately change. These are just completely different. So these would not be similar. These are similar. So these 2 triangles are similar. They have the same angle sizes, but they don't necessarily have the same length. Okay, next page.